Okay, you guys ready to go through them? You can make corrections if you wanted to. The first one talks about the position time graph, and you were asked to describe how the person was walking. So things that I was looking for would be a direction to make sure you got forwards and backwards, or you could have worded it as towards or away from. I was looking for those directions indicated. And then also some sort of indication that the velocity was constant. And then also you could get even more points if you said what that velocity was. So for each of these, I'm going to go through and we'll talk about what you should have had written for the whole graph. So it looked kind of like this. And then it went to the end. Okay. So on this first section, right here, from A to B, is that toward or away from the origin? Toward. Okay. So the motion detector was at the origin, so they're starting at 6 meters and walking toward it. So that's where you get that downward slope. So this section would have been toward the origin. Is that a constant velocity or a changing velocity? Constant. And you should have gotten 2 meters per second. If you indicated the negative sign, that's okay. Or if you just set a speed of 2 meters per second and then indicated towards, that would have been correct. For the other part, when they switched directions, some of you showed that they definitely went away. You said they changed directions, and you mentioned that they went at a slower pace, which is correct because that's not quite as steep of a slope. And to get the full points, you would have had the actual value for that slope. So you could have said +1 or 1 meter per second in the away direction or positive direction. What's happening right here? Yeah, they stay still. So I think everybody got that part right. Okay, so they're standing still for however many seconds that was, 3 seconds. And then on this portion from D to E, toward or away? Toward. And they actually reached the origin because it does go down to that x-axis. So they went all the way to 0, and that slope was a -1.2 meters per second. And then I think only a couple of people missed it. There was a little section right here. So they did stand still for that part as well for another 2 seconds before the time stopped. And I was trying to grade you the way that the AP test is going to grade you. So I know some of you, you're like, well, I got toward and away, I just didn't put numbers down, or I didn't indicate a constant pace. They have rubrics, and every little thing gives you more and more points. So that's why I was really hard on you on grading some of the paragraph forms. Okay. And I'll go over that with the math questions too when we get to those as well. Does anybody have any questions about that first one? Okay. For our second one, make the axes a little bit bigger. On this one, they went that part, up, over, down, up, down. Oh, that's the origin, sorry. And up and over. Okay, so it should look something like that. You had to kind of shift your way of thinking a little bit because most of us do position time graphs really well. You have a good indication of forwards and backwards with that one, but these are going to be a velocity time graph. So anything in the positive part in that first quadrant, that's going to be considered positive movement away from the origin. So anything that's up in this area is away. Anything in the negative part is toward. I did that backwards. No, I did that right. Sorry. So anything down in the bottom is towards. Okay. If they have any kind of negative velocity at all. Because a plus and a minus tell you a direction. So a positive value for velocity is away, and a negative value for velocity is toward. Okay, so with that in mind, down here, toward or away from? Toward. Toward, good. So they were walking toward the origin. Okay. Is that a constant velocity or a changing velocity? Constant. Constant. Okay. So a constant velocity, and it happened to be -2 meters per second. You could just read that right off the y-axis. Okay. And then this vertical part, this is letting you know when they switch directions. There's no actual movement on that vertical jump. That's when they change. So that's like the hesitation to switch directions. So then we've got this portion, okay, and it's a positive value, so you should have away from. You could have said backwards for towards and forwards for away. That's acceptable as well. And that's also a constant velocity. And it was, some of you just said the speed, which was fine if you indicated away from as well, but that was 1 meter per second, and that was read off the y-axis as well. This part that slants, this is where it gets tricky, okay? So, a lot of people missed thinking that that's all in the same direction, because on a position time graph it would have been. It's one movement. But remember, anything up here, I'm going to make this a little bit bigger, right here, that's a positive velocity. Are they walking toward or away from?
Away.
Away, good. So that portion right there, they're walking away. I know it seems kind of backwards because you're approaching that axis, but it's a velocity graph. The velocity is approaching zero, not the person. So by virtue of it being a positive value, that means they're walking away. Okay. Did their velocity change during that little tiny section? From here to here?
Yes.
Yes. So did they speed up or slow down?
Slow down.
They slowed down because they had a positive 1 meter per second, and then it went to 0, okay? At that point, once they reach this portion and they had 0 velocity, look, do they keep going in the same direction or change directions? Yeah, they change directions. So here, they end up going toward the origin. Because it's a negative value for the velocity, you're approaching the origin or the motion detector. Does their speed increase or decrease for that green section? Good, it's increasing because it goes from 0 to a value of 1, and it happens to be in the negative direction. So they were speeding up here. And I think there were probably maybe like 4 or 5 of you that got that section. So if you didn't get it, don't feel left out. It was a really common mistake. I just want to make sure that we took time to go over it. Yes?
I have a question. It said that the motion detector was like at the origin, but wouldn't that mean that it's like one way? Because the way I'm seeing it now is as if the motion detector would be like at the bottom, at the -2.
That would be true on a position time graph.
Okay.
So the velocity time graph, when you have a plus and a minus, anything positive, I'm going this way, and anything negative, I'm going this way. That's the only thing that's different. They're not actually going on the other side of a motion detector. Had it been a position time graph, that would have been true. Okay. What was your question?
I think I just had like a error in ordering, I think.
Does anybody else have a question on that sloped part? Okay. And then what happens right here?
They stop.
Yeah, they stop. Okay. They don't have any velocity at all for those 2 seconds. So they're stopped from 12 to 14 seconds. Okay. And then it jumps, so now we know they're going to be moving. Is that last portion toward or away from? Okay. Away. And it was a constant velocity of 2 meters per second in that positive direction. Based on that up and the down, that there was a parabolic motion to it. If yours did this, I took off a couple of points, okay? Because that's not a constant velocity. You should have a parabolic motion to it. The top of your parabola would have hit the 4 meter mark, and then your time was 4. And some of you had asked during the test, you were assuming that it was symmetrical. We don't have any kind of air resistance or anything like that in our happy little physics world. So a nice symmetrical parabola for the up and the down. Okay. On the velocity time graph, some of you recognize that part of it was positive and part of it was negative. Okay. What's different was where that occurred, like how it was changing and what direction you had. It was a changing velocity. So think about something, if I move it upwards, okay, it told you that up was the positive direction, so you know you're going to start on the positive part of that y-axis. When you throw something upwards, does it speed up or slow down? It slows down. So we started with some value that was positive, and it slows down. Gravity treats everything the same. It slows it down at a constant rate. So the velocity was consistently changing the same amount every time. And then as it falls, did it speed up or slow down? Speeds up. And that was the part you had in your summer assignment. So your summer assignment, you should have had, this is one line with the same slope the whole time. On your summer assignment, you should have gotten a straight diagonal line. Yours might have been positive or negative depending on how you did your coordinates system in your tracker. But for this one, it told you up and down which directions each one was. What time do you think it crossed from up to down? 2. It was in the air a total of 4 seconds. So at 2 seconds would have been the midpoint. 4 is where you end everything. Okay. And did you figure out what the velocity was? Did anybody get a number for that? So if it goes 4 meters up, okay, and then 4 meters down, and it's in the air for a certain amount of time, so 4 meters up in 2 seconds, okay. So you should have started at positive 2, and then that would have made it end at negative 2. And then from your summer assignment, what did you find for the value of gravity? 9.8. So on our acceleration time graph, does gravity change? Nope. It's constant the whole time. So for those entire 4 seconds, your acceleration should have been the same because it was due to gravity. And it would have been a negative 9.8 meters per second squared for the whole time. So and the only reason for that in this case is because they specifically indicated in the directions that down was negative and gravity pulls down. So that's what made it a negative number. And most everybody did really, really well on these 3 problems. So I'm going to kind of quickly go through them. But if I go too fast or I miss something, you have a question, let me know. I'm going to use the guess method. I don't know if you've ever seen that before, but it's just a way to write down and show as much work as possible. Okay. So the G stands for the givens. So that's what we're going to do first. I know that my object falls a distance of 3.1 meters. I know that the acceleration is due to gravity, so I could have written an A or a G. Okay. And when you drop something, what's the initial velocity? 0. So we know we have a VI of 0. And then you were asked to find how long does it take to reach the surface. So our unknown would be time equals question mark or whatever, however you want to write that. The E tells you write the equation. Okay. So you were going through your kinematic equations, look down that list, and match up the equation. You should have gotten the second one, which looked like this. And since we had an initial velocity of 0, I can cross out that term and just start with this as my equation. Because I had no initial velocity, I don't need that value for time either, because whatever it was going to be times 0 anyway. Okay, so that just kind of simplifies a little bit. From here, you can plug numbers in. So that's what the next S is, substitute, okay, in our guess method. So I would substitute in 3.1 meters. And then 1/2 the 1.65 meters per second squared. And then we would have t squared. And the last S stands for solve. So you just solve the equation from there. Some of you had asked about gravity, if it's always negative or not. technically, you could put a negative sign in as well, but if you did, and you made gravity negative because it's going down, you also have another number that would have been negative. Keep thinking. The velocity would be, but we don't need it in this one. What else was down in the givens? Yeah, the distance. So it actually fell a negative displacement, and you had a negative value for the acceleration. They would have canceled out, so that's why I didn't put them in the first place. So your signs would work themselves out had you indicated down as negative also. You should have come up with a time of 1.9 seconds total. Okay, so that was your final answer. Questions on that one? Okay. So you guys are pretty good to remember to take square root at the end on the time. Our next one, you were given a distance. It was 0.88 kilometers. The time was 8.7 seconds, and it did start from rest, so we also have an initial speed of 0. And you were asked to find the acceleration. And it did say the magnitude of, so if you went ahead and put the plus sign, I went ahead and gave you credit, I didn't take off anything, but when it says magnitude, that means just the number. You don't have to write the sign in it. So just a little detail on that word. Some of you guys had missed that on your quest as well. You kept typing the negative, but it asked you only for magnitude, so just don't type the negative sign. On this one, it happened to be the same equation, but I put this one in there because I wanted you to be aware of your conversion. So what should distance be measured in? Meters. Okay. Do you know how to convert kilometers to meters? Okay. I'll go ahead and write it out for those of you. Yeah. Because our acceleration is meters per second squared. A couple of you guys put your answers in kilometers per second squared, and I went ahead and gave you credit for that one, or maybe like 1 point if I did take off anything. But the standard unit for acceleration is meters per second squared, so that's why you should convert. So you would have 1 kilometer has 1,000 meters. So you end up multiplying. And your formula was the same one as number 1. Again, you didn't have an initial velocity, so that whole term canceled, and it reduced down just like the previous question did. You were just rearranging and solving for a different variable. You should have gotten about 23 for the acceleration. If you did not convert and you said 0.023, then your units should have been kilometers per second squared instead of the meters. So I look to make sure that your decimal and your units match up with each other. Anything on that one? Go over.
So
yeah.
If we got it right in kilometers per second, we're still supposed to convert it to meters.
On the AP exam, yes.
Okay.
And it would be make sure the seconds were squared on it. Okay. So let me know on that one. I can go back and look at that too, if I made any mistakes for you guys. Okay. And then your last one on this page did use the vector notation for the velocity. So you were given a velocity. When you rearranged, the time would have been final velocity minus initial velocity over acceleration. When you plug those numbers in, you end up with a negative value on the top because you're subtracting that initial velocity, and then you had a negative value for the acceleration because it decelerated, it slowed down, so you had to supply that negative sign. And you should have come up with a time of 18 seconds. If you didn't remember a negative sign, when you got to the end, you should know that time's not negative, so just make it a positive value if you forget. Last page. To go quickly, you see my battery warning came up, down to 10%. Get you going, let you work on your extra credit. Most people did pretty well with the cheetah and the antelope question, and again, I was really hard on you for showing your work simply because that's how the AP graders do that. Yes, you get points for having the correct answer, but you also get points for knowing the formula and for showing your work and making those substitutions. So if I was harsh on you, that was the reason, okay? Because on the AP exam, you do get points for every little step. They have a rubric that they go by, and they're really strict about that. So I'm just going to kind of quickly mention a couple of these things. You should have changed either the speeds from kilometers per hour to meters per second, or you would have had to change the other values because it gave you seconds for the time interval. You would have had to make that into hours if you hadn't changed the speeds, and you also would have had to put that head start into kilometers if you had not changed the speeds. So you want your units to match up so you can compare them accurately. When you change the speed of the antelope, you should have gotten 25 meters per second, and the speed of the cheetah would have been 32.5, just to kind of check your work on those. And then you had a time of 30 seconds. There were a few different ways that I saw people solve the problem. I'm just going to show you one of them. Okay, so if you think you solved it correctly and you want me to double check your numbers, if you think I made a mistake, just let me know. But on this one, you want to know how far each of them could travel in that amount of time. So for the antelope, you want to take its speed times those 30 seconds. So you'd have 25 times 30. And he was able to travel 750 meters in those 30 seconds. The cheetah, with his speed for those 30 seconds, is able to travel 975 meters. Okay, so think about the head start. The antelope got that extra head start of 150 meters. What's 750 and 150? Yeah, 900. The cheetah can go more than 900, so it does catch up. So the way it was worded, can the antelope outrun the cheetah? The answer was no. And the reason for that is because even with the head start, the cheetah's still able to travel more of a distance, and he would have caught up. Some of you guys worked out time intervals, and you told me when they would hit. That's fine. As long as you did that correctly, I gave you full points for showing me all the work on that. Okay, so some of these have more than one solution. And then our last one, again, some of you guys did this in different ways. I'm just going to show you one method. Okay. We've got car A and car B. And we know that they are 455 miles apart. Everything in this question was miles and hours and miles per hour, so I didn't bother with any of the conversions. We know that B has a speed. We don't know what it is. Car A is how much faster than car B? Good, 10 miles per hour. So we know that its speed's going to be whatever the B speed was plus 10. And then we know that the two distances together are going to add up to the 455. So however far car A travels and however far car B travels, it's going to add up to 455 because that's how far apart they start. So what I'm going to do from the distance time speed formula, I'm going to substitute in a little bit for that. So my total distance of 455, for the distance of car A, I know that it's going to be his speed times the time. And for the distance of car B, I know that's going to be car B's speed times the time. I'm going to make a substitution. So I'm going to keep my 455. Instead of writing the speed of car A, I want to get this down to one variable. So I substitute it in. And now I can substitute in my time because you were given 3.5 hours for the T, and you can solve for the speed of car B. So we would have VB plus 10 times the 3.5 hours plus VB times the 3.5 hours. And some of you guys set up a system of two equations a little bit differently, but you still arrived at the same solution. You showed me your work, you got the right answer, I still try to give you points for that. So if I did make a mistake and you think you were correct, let me know, and I can go back and look at your test, make sure you get the points you deserve. Overall, you should have gotten the speed for car B to be 60 miles an hour, and that would have made car A traveling at 70 miles an hour. And some of you guys knew that there was a 10 mile an hour difference. You just plugged in different numbers. and you solved for the distances and waited until you found one where the distances added up to 455, that's okay. So if you did that and you still got the right answer, as long as you showed your steps and your method, that was correct. Also, some of you did a graph as well. If you showed a graph, you had to tell me how you got those slopes so that I knew where they would cross. You did that correctly on your graph on showing the meeting point, but you may not have said how you knew what the slopes were to see where that happened. To find your total distance for each, actually, you solve something a different way, and maybe I didn't give you the points you think you deserve, just let me know, and I'll come look at those again. Because some of these do have multiple solutions. Good? Okay.